Hi, and welcome to the videos for Chapter 3 for Math 126. These are the videos for Section 3.1. There's two videos in this section, and this is the first of the two. In Section 3.1, we're going to be looking at quadratic functions and models. So, let's look at a few definitions before we start here. First off, a quadratic function is a polynomial of degree 2. For example, if we have f of x is equal to ax squared plus bx plus c is equal to 0, as long as a is not equal to 0, meaning that we have some x squared term there, then this is what's known as a quadratic function. We can put this function in what's known as standard form. That's our next definition here. So standard form of a quadratic function and that has the form as follows. So the function f of x, which is ax squared plus bx plus c equals 0, is equal 0. So the function can be expressed in standard form which is a times x minus h squared plus k, and we can convert from this function to this form by completing the square. So you can see we've already been doing this a few times this semester. So really important to understand the methodology of how do we complete the square. This equation here, the standard form, this has the form of what? It's a parabola, right? So we know that anything to the x squared is going to be a parabola, and then it gets shifted around. The value for h on the inside, that's our vertex, the x-coordinate of the vertex, moves it left or right. The a does what? That's our stretching or shrinking, and the k is our vertical shift, which gives us our y-coordinate. So we can actually write that down then, that the graph of f is a parabola with vertex, so that's the point where the parabola has the top of the hill or the bottom of the cup. So it has vertex, and again, the h is inside, so it's the opposite of what we see. So its vertex is h, and whatever this value k is on the outside, if it's positive, it's a positive number. If it's negative, it's negative. And the parabola opens up if a is greater than 0, and the parabola opens down if a is less than 0. So if you're given a function, and it's a quadratic function, and you're asked to graph it, you don't necessarily have to plot points. If you convert it to standard form using your transformation of graphs methodology that we learned earlier in the semester, you can graph it in that manner. So let's look at an example. So let's express f of x is equal to 2x squared minus 12x plus 23 in standard form and graph. So, what we're going to want to do here is we need, as I said, we have to complete the square. And so what I really want to look at is this first part here. This 2x squared minus 12x. So actually let me leave a little more space here. And then plus this 23. When we complete the square, what is the first thing we have to be concerned with? Well, that's what? That's the a, the value in front of the x squared term, has to be 1. So how do I do that? Well, with the pieces inside the parentheses, I'd have to factor out a 2. So when I do that, I'm left with x squared minus minus 6x, because we're factoring out that 2, and plus 23. And again, you can check it. So if this is on an exam and you're like, boy, did I do that right or not? What can you do? Just distribute it back. 2 times x squared is 2x squared. 2 times negative 6x is minus 12x plus 23 is what we started with. So that's okay. So now, if I complete the square on the piece inside here, my b is what? My b is minus 6. 1/2 of b is negative 3. And 1/2 of b, if I square it, is positive 9. So, here's where we have to be careful now. I need to put a plus 9 on the inside here. But what did I do to this whole expression? Well, I didn't just add 9 because I have this 2 in front. So 2 times 9 is 18, which means to this original piece, I've added 18, and the only way to keep it originally as it was would be what? Would be to subtract 18 from the same line of the equation. So let's look at something like this. If I had, let me fit it in here. If I have 3 plus 4, that's what? That's 7, right? So I can say I'm going to add 18, but that's no longer what I originally started with. I started with 3 plus 4 is 7. So if I'm going to add 18, I also have to subtract 18. Now what do I get? These two cancel out, so I'm left with what I started with originally. Same idea here. 2 times 9, if I was to distribute this and expand it out, is 18. So because I added 18 here, I also have to subtract it in the same line to make sure that I didn't change the problem that I was given to begin with. So now this becomes a perfect square trinomial, so it's what? It's 2x and half of b is minus 3. So it's x minus 3 squared, and then 23 minus 18 is 5. So this is my function in standard form. Now it asks me to graph it. Well, this is my a. It's positive, so that means what? This means it's a parabola pointing up. And the vertex is where? The vertex, I see negative 3, so that's plus 3. And I see positive 5, and because it's on the outside, stays positive 5. So my vertex is at 3, 5. So if I was to graph this, I know the bottom of the parabola, because it's pointing upward, is at 3, 5, 3 to the right, 5 units up. And because it's pointing up, it's going to look something like that. So I didn't need to sit there and plot all these different points and do all the calculations, because again, some of these numbers might get pretty ugly if you have, say, 4x squared and now you start plugging in these numbers. So we don't want to do that. If we put it in standard form, we know which way it's pointing depending whether a is positive or negative, and then where the vertex is at. So that's it. That's the end of video 1. Come on back, we'll look at the second video, which will wrap up section 3.1.